Hello everyone. Welcome to this tutorial on switch interfacing with PIC16F877A. In this session, we will learn how to use external pull-up and pull-down resistors for reliable digital input and LED control. So let's start our session with checking what is a switch. A switch is a device that connects or disconnects a circuit. Or we can say a switch converts physical human action into electrical signals that a microcontroller can process. When the switch is open, no connection exists. That is, the current won't flow. But when the switch is closed or pressed, a complete circuit is formed and hence the current flows. The microcontroller interprets these states as digital values. 5 volt represents high with logic 1, whereas 0 volt represents low with logic 0. Now let's understand a very important problem in digital electronics called floating input. When we connect a switch to microcontroller input without connecting firmly to either VCC or GND through a resistor, it doesn't get a fixed high or low value. Instead, it picks random noise from the environment. This unstable condition is called floating input. So, think of an input pin of microcontroller like a decision point. Okay, think the input pin as a decision point. So, it must be either connected to VCC or ground. Okay, the pin must be either connected to VCC or ground through a resistor. If it is not connected to VCC or ground through a resistor, what happens is it will pick, that is, the pin will pick up random noise from the environment. So, the value of the pin will toggle from high to low or low to high randomly. Okay, this condition is known as floating point. Did you understand? Okay, so this creates unpredictable behavior of your circuit. Clear? And the problem include random high or low values even without pressing any button. Okay, so without pressing the button itself, the value of the pin may change from high to low or low to high. Clear? LED flickering can occur. System errors due to unreliable readings. Okay, a simple way to understand this is imagine a person, okay, who cannot decide yes or no. Imagine a person who cannot decide yes or no and keeps changing the answer. Okay, so you can imagine this condition as a person who cannot decide yes or no and keeps changing the answer. To solve this problem, we have two solutions. They are external pull-up resistor solution and external pull-down resistor solution. Now we'll check what is external pull-up resistor solution. So first of all, to solve this problem, we are using pull-up resistor. Okay, we are using pull-up resistor. So this one is the pull-up resistor. A pull-up resistor is connected between the input pin of the microcontroller and VCC, while the switch connects the input pin to ground. Clear? Once again, this one is the pull-up resistor. The pull-up resistor is connected between the input pin of the microcontroller and VCC, and the switch connects the input pin of the microcontroller to ground. Now let's check the working. When the switch is not pressed, the input pin is connected to VCC through the resistor, and hence the input pin of the microcontroller reads a high value. Clear? Now assume that the switch is closed. Okay. Now the pin is connected to GND directly. Okay. And hence the microcontroller will read a low value. Now, what is the need of this? And how is it helpful for the circuit? This prevents floating, that is floating input. Okay, this prevents floating input. It provides a defined voltage level. It ensures stable input and limits the current to avoid short circuit. Okay, now let's check what is external pull down resistor. So this is a circuit for external pull down resistor. A pull down resistor works in the opposite way of pull up resistor. So this is the pull down resistor. The pull down resistor is connected between the input of the microcontroller and GND. Okay, the pull down resistor is connected between input of the microcontroller and GND, and the switch connects the input of the microcontroller to VCC. Switch connects the input of the microcontroller to VCC. This type of connection is known as pull down resistor. Okay. Is that clear? Now let's check the working. In the case of pull down resistor, when the button is not pressed, that is when the switch is not pressed, the pin is connected to GND through the resistor, and hence the microcontroller will read a low value as default. Okay, when the switch is not pressed, the microcontroller will read a low value since the input pin is connected to GND through a resistor, through a pull down resistor. Now assume that the switch is pressed, okay, and the circuit is closed. What happens is the microcontroller will read a high value because the switch connects the input pin directly to VCC. Okay, so it reads a high value. Is that clear? Okay, in the case of pull down resistor, if the switch is not pressed, the input pin is connected to GND and reads a low, and when the switch is pressed, the input pin will be connected to VCC and hence it will read a high value. Clear? Okay. Now, to remember this easily, you can see pull up means default high. Okay, that is you can connect up and high together. Pull up means default high. Okay, up and high. Pull up means high and pull down means default low. So you can connect down with low. Okay, pull down means default low. Okay, now let's check the comparison between pull up and pull down resistor. In pull-up resistor, the default state is high, and pull-down resistor, the default state is low. In pull-up resistor, the press state is low, and in pull-down resistor, the press state is high. And in the case of pull-up resistor, the resistor connects to VCC. The resistor connects to VCC, but in the case of pull-down resistor, the resistor connects to GND. Okay, and in the case of pull-up resistor, the switch connects to GND, and in the case of pull-down resistor, the switch connects to VCC. And even though both of the resistor configuration reduces the floating points or floating inputs, pull-up resistors are commonly used than pull-down resistor. Okay, pull-up resistors are commonly used than pull-down resistor. So with this, the theory part is over. Now let's see how you can interface an LED and a switch along with microcontroller. Okay, so let's start. So this is a circuit to control the LED using a switch and microcontroller. Clear? So you can see that the switch is connected in the pull-up resistor solution. Okay, it is connected in the pull-up resistor solution. and it is connected to the port B, that is RB0. Okay, and the LED is connected to port B itself, but RB1. Okay, so switch is connected to RB0 and LED is connected to RB1. Here, a single port itself is used as input and output. That is, RB0 is connected as input or used as input, and RB1 is used as output. Okay, now let's check how to connect the switch. Okay, so RB0 is connected to VCC through a resistor. Okay, and again the RB0 itself is connected to switch, and the switch is connected to GND. Okay, so you have to configure the switch like this to avoid the floating point. Clear? Once again, RB0 is first connected to VCC through a 10K resistor, and the same pin is connected to switch, and the other point of the switch is connected to GND. Okay, now how to connect the LED. The LED's positive is connected to RB1. The LED's positive is connected to RB1 through a resistor, through a 220 ohm resistor, and negative is connected to GND. The LED's negative is connected to GND. Okay, now how should this work? Okay, when the switch is not pressed, the button is not pressed, the LED should turn off. Okay, but when the button is pressed, okay, when the button is pressed, the LED should turn low. This is how the circuit should work. Now, can you tell me what will be the default state of RB0? Yes, the default state of RB0 will be high because it is configured in pull up resistor. Okay, and when you press the button, the pin RB0 goes to low and then the LED should turn on. Okay, so let's go and check the program side. Clear? Okay, so program logic for LED control. First, what you have to do, first you have to create the project. You have to go to MPLAB and create the project. You can give any project name. Then you have to create the configuration bits. And after creating the configuration bits, you have to copy it and paste it in the main program. Okay. And inside void main, you have to write this program. Okay. So what we are going to do is, here we want RB0 as input. Okay, so to set a pin as input, you have to give 1 to that bit. And RB1 should be output. So here, TRISC-B should be configured as 0B00000001. Okay, so the last pin, that is RB0, is configured as input. That is why it is 1. And rest of the pins are configured as output. Okay, now we are going to initialize the pins. For that, you are giving port B is equal to 0. Okay, port B equal to 0 means the entire port value will be changed to 0. Okay, that is entire port value will be initialized as low. Is that clear? Okay. Now you know that to make the program work continuously, you need a while one, and inside while one, you will be writing the entire program. Is that clear? Okay. If here you are going to check the condition, that is, when the button is not pressed, the switch is not pressed, you know that it will be in high state. RB0 will be in high state. And if the button is pressed, it will go to low. So you have to check here whether the button is low. Okay. So to check a condition in the program, we use if else. Okay. So to check the condition, we are using if else. Okay. So here we are going to check if the button is pressed. So First, you have to write if, and in brackets, you have to check the condition. What is the condition? RB0 is equal to low. Okay, to check the condition. For comparison, you have to use double equal to. Okay, for checking a condition or for for giving comparison, you have to use double equal to. So here you are using RB0 is equal to 0. Okay, RB0 is equal to low. Okay, so what happens if RB0 is equal to low? Yes, when RB0 is low, the LED should turn on. For the LED to turn on, you have to give a high to RB1. So RB1 equal to 1. Okay, if you give RB1 equal to 1, the LED turns on. Okay, now what should be the condition if RB0 is high? Yes, if the RB0 is high, the RB1 should be low because the LED should turn off. Okay, so that condition you have to give in else. Okay, if you have to check two condition, we usually use if else statement. Okay, so in the if statement, we are giving the condition to check whether RB0 is equal to 0, and in the else, it automatically check the opposite condition that you have given in if. Okay, so here you have given the condition that is given what you have to do if RB0 is high. Okay, so if RB0 is high, RB1 should be low. Okay, if RB0 is high, the RB1 pin should be low. That is LED should be off. Okay, and then you have to close these brackets. This is the program to control the LED using switch and microcontroller. Okay, so the program continuously checks where the state of RB0, and if RB0 pin is high, the LED will be turned off, and if RB0's zeroth pin is low, the LED will turn high. Okay, so let's go and check how you can configure the circuit and how you can program it. Clear? So we are going to create the program for LED control using switch and microcontroller. Okay, or turn on and off LED using the switch and microcontroller. For that, first we have to set the configuration bit. Before that, you have to go to file and create a project. And after creating the project, you have to create a source file, etc. After that, only you have to create the configuration bit. For creating the configuration bit, you can't see the window over here, right? So I'm going to click on window and then target memory views, and in target memory views I'm taking configuration bits. Okay, so here you know that FOC should be HS, right? Why it should be HS? Because our crystal oscillator frequency is greater than 4 megahertz. That is, the crystal oscillator frequency of our microcontroller is 16 megahertz. So it should be, that is HS should be selected for that. Okay. If the crystal oscillator frequency is less than 4 megahertz, you have to select XT. And if the crystal oscillator frequency is equal to or less than 32 kilobytes, it should be low power or LP. Okay. So here, this is 20 megahertz. So I'm selecting HS. Okay. And as you know, I have to turn off all rest of all the bits. So after that, you have to generate the source code, and I'm going to copy it and paste it here. Okay, and then do the rest of the program. So here I have to give the clock frequency, hash define, underscore, space, underscore. Okay. And then you have to set the port for the switch. So I have taken Proteus and I have taken some components that is required for our project. They are PIC microcontroller, switch, LED, crystal, then capacitor, then two resistors. Okay. So I'm going to connect, I'm going to create the circuit. So first I'm selecting the PIC microcontroller and placing it over here. Okay. Next I'm going to create the crystal oscillator to provide the oscillator frequency. So I'm going to rotate it. Okay. Now here I'm going to connect the crystal oscillator to pin number 13 and pin number 14. Okay. And second terminal I'm going to connect it to 14. Okay. And to the X1, to the two terminals of crystal oscillator, I'm going to connect two capacitors. So I'm placing it over here, and second one I'm placing it over here. Okay, so connect the capacitors to the crystal oscillator, and the other side of capacitors are grounded. Okay, so take the ground and place it over here. Okay, so the connection is completed. Next, I'm going to take power and connect it to MCLR. Okay, okay, it is completed. Sorry. Okay, once more. Okay, now the connection is completed. Now we have to connect the switch and the LED. So first I'm going to connect the switch. So we are connecting the resistor for the switch in pull up configuration. So I'm first of all I'm taking 10 kilo ohm resistor. Since this is 10 kilo, since this is connected in pull up configuration, I have to connect one side of the resistor to the input pin, that is RB0, and second side should be given to VCC. Okay, so I'm taking the power and giving it over here. So this section is completed. Then I'm going to connect switch in between the input terminal and GND. So I'm taking the switch and keeping it over here. Okay, and one terminal is connected to input, and second terminal I'm going to connect it to GND. Okay. So this session is also completed. Now we want to connect the LED to RB1 through a resistor. So first of all I'm taking 220 ohm resistor and I'm placing it over here. Okay. And then I'm taking the LED and I'm placing it over here. Okay. Now this first terminal of resistor is connected to RB1. Okay. Okay. Next, second terminal of the resistor is connected to positive terminal of LED. Okay. And negative terminal of LED is grounded. So I'm taking the ground and keeping it over here. Okay. So it is grounded. Now the circuit connection is completed. Okay. So let us go and check the programming area. Okay. Now I have completed the program. Let us build it. Okay. So I'm going to build the main project. Okay, the building is completed and I'm going to copy this path. Okay, so I'm going to copy this path. Now let's start simulation of the project in Proteus. Okay, so I have opened Proteus and this is the circuit that we have already created. Now double click on it. First change the clock frequency to 20 megahertz and then I'm going to paste the path in the program file. Okay, and click on OK. Okay, now let's start the simulation. So click on run. Now you can see that the switch is open and the LED is off. Now I'm going to close the switch. So when you close the switch, the LED is on. Okay, again when you are opening the switch. In this video, we have discussed about switch, what is floating input, then solution for floating input, that is pull up and pull down resistor, and how to connect an LED or how to control an LED using switch and microcontroller, its hardware and software part, and along with its simulation. Okay, so with this, I am concluding my words. Thank you for watching the video. Bye.